An open box is to be made from a rectangular sheet of card measuring 16 centimeters by 10 centimeters. 4 equal squares are to be cut from each corner and the flaps folded up. Find the length of a side of a square which makes the volume of the box as large as possible and find the maximum volume. So we've got this rectangular sheet of card which measures 16 by 10, and then we cut X from each corner like this, and we fold up. Now this is going to be 10 minus 2x, this bit here, and that would be 16 minus 2x. So when we actually fold up and get the box, it doesn't have a lid. When we fold up, this is going to be x, this will be 16 minus 2x, and this will be 10 minus 2x. So the volume of the box is going to be x, 16 minus 2x, 10 minus 2x, just length times width times height. So what we need to do is expand that out. So we'll get 16 times 10, which is 160. Then we're going to get minus 20x. So minus 20 minus 32. So that's going to be take away 52x. And then plus 4x squared. So the volume is going to be 160x, take away 52x squared, plus 4x cubed. So dv dx would be 160, take away 104x, plus 12x squared. Now we want this to be 0, so that's 12x squared, take away 104x plus 160 equals 0. We can certainly divide through by 4, which is 3x squared, take away 26x plus 40 is equal to 0. Now, it may take you some time to spot factors. You can use your favourite method if you're going to factorise. Or you could use the quadratic formula here. 3x and x. If I put 20 here, and I put 2 there, and make both of those negative, that will do the trick. So we get x is equal to 20 over 3, or x equals 2. Now, this one here is not valid. 20 over 3 is 6 2/3. You just simply can't cut out 6 2/3 from 10 on this side. So it has to be the x equals 2. So we've found the length of the side of the square because that was x, and then we want the volume. So we're going to substitute that in, and that's going to be 160 times 2, take away 52 times 2 squared, plus 4 times 2 cubed, and that gives me 144 cubic centimeters.